In this video, we'll dive into the 6 most common SQL joins every developer should know. I'll break down each one, explaining the underlying mechanics, exactly how tables are joined, how SQL populates the results, and the best scenarios for using them. Plus, check the video description for a Docker image with step-by-step instructions on how to follow along and verify the outcomes yourself. Let's start with inner join, which is the most common type of join in SQL. It is used to combine 2 or more tables based on a related column between them, which frequently defines the relationship between these 2 tables by using primary and foreign keys. But to join tables, you can use any columns of any type, like integer, string, and so on. The most important part is that the values in both columns match. When you use this join, it returns data that is present in both tables. You can think of it as the intersection of 2 sets of data. Let's go over a simple example. Let's say we have a table that keeps track of users and their friends on Facebook. On the other hand, we have a table for LinkedIn with mostly the same users and their connections. Now we want to combine these tables and find how many friends and connections a user has on both Facebook and LinkedIn. And we don't need users who have only a Facebook account or only a LinkedIn account. For that, we can write the following SQL query. We'll use star to collect all columns from both tables. In the real world, you would define specific columns you want to select. Then we specify the first table and the second table. Inner join is the default join, so you can just write join. Next is the most important part for the join. You need to specify the columns that SQL will use to match the values in join tables. So in our case, the name in the Facebook table must match the name in the LinkedIn table. When you execute this query, the first thing it will do is create a new table with columns from both tables. It then tries to find values that match between the columns you specify in the on statement. It starts with the first value of the specified column in the first table. In our case, it's facebook.name, and then looks through every value in the specified column of the second table, which is linkedin.name, for a match. If there is a match, it copies the data from both the row of the first table and the row of the second table and puts it into the newly created table. SQL will not add in any rows that did not have a match. Then it goes row by row to find matches in the entire table. You can execute exactly the same SQL query using my Docker image that I provided to practice and verify the results for yourself. You should use an inner join whenever you need to retrieve data that relies on a strict relationship between tables. Maybe you want to see orders along with the specific customer who placed them. Or just filtering incomplete data, like in this example where we ignore users if they are not present in both tables. Or maybe when you want to ensure that your final report doesn't contain null or empty associations from either side. Now let's take a look at the second most common type of join in SQL. You use a left join, also known as a left outer join, when you want to retrieve all records from the primary left table, regardless of whether there is a matching record in the secondary right table. When you execute this query, it will again create exactly the same tables with columns from both tables. It will start from the left table and compare values in the right table pretty much the same as in the previous inner join example. But the biggest difference is if there is no match on the right table, it will still add the row from the first table and put nulls for the columns from the other table. You might use this join to identify missing data or gaps. For example, find all customers who have never placed an order, or to preserve the master list when the right table is optional. Or, when building dashboards, you often need to show a complete category list even if some categories have 0 activity. Next is the right join, which is one of the rarest types of join in SQL. The reason for this is that any right join can be rewritten as a left join, which is more conventional. Right refers to the second table or the table you will be joining. So in this case, it would be the LinkedIn table since it comes after the Facebook table in the query. This could be rewritten as a left join and produce exactly the same results. However, let's look at the process of a right join in order to see how it works. It changes which table SQL evaluates from. It starts with the first value of the specified column in the second table. In our case, it's linkedin.name, and then looks through every value in the specified column of the first table, which is facebook.name, for a match. It goes row by row and appends values if there is a match. Full outer join is the third most common type of join in SQL. It returns all records when there is a match in either the left, Facebook, or the right, LinkedIn, table records. First, this query finds matches and adds them to a newly created table in the same way as a left join. It starts from the left primary table and goes one by one. Now, after completing the left join of the data, a right join is essentially performed. But since all the cases where there is a match have been made, SQL only checks to see if each value is present in the join table. If it is not in the join table, SQL will add this row to the new table and put in nulls for the columns from the other table. In our example, we can use this join to find how many friends and connections your Facebook friends or LinkedIn connections have. It ensures no data is lost from either side of the join. It is best used when you want to identify gaps in your data. For example, finding orphaned records in both tables at once. Union does not attach the data from two tables to a single row like SQL joins horizontally. Instead, union stacks two datasets on top of each other into a single table vertically. When you perform a union, data columns can have different names like friends and connections. The important part is that they have the same data type and the same order. Now let's create a master list that would contain all social contacts for each person. Even though the column names differ, friends versus connections, the operation works because the data types, string and integer, match. Also, we use union all to get the complete list of users. Union, on the other hand, removes duplicates. For example, if Olivia would have the same number of friends and connections, well, the second entry will be removed as a duplicate, but since it's from different social networks, we want to keep it. And finally, we have a cross-join, also known as a Cartesian product. It doesn't look for a specific relationship or matching IDs between tables. Instead, it pairs every single row from the first table with every single row from the second table. Think of it like a matching game where every possible combination is created. In our case, we have a table for t-shirt sizes and another table for colors for an e-commerce website. And we want to generate a list of every possible product combination we offer. It can be useful for performance testing as well when we need to quickly populate a table with thousands of rows. Just be careful using cross-join on large tables. If table A has 1,000 rows and table B has 1,000 rows, the result is 1,000,000 rows. If you accidentally cross-join two tables with 100,000 rows each, you could potentially crash your query or slow down the database significantly.